How does pyrazinamide work as a prodrug for TB? Imagine a medication that only becomes active once inside the bacteria causing tuberculosis. That's exactly how pyrazinamide functions. It is a key drug in modern TB treatment because it can shorten therapy and target bacteria that other drugs might miss. But it doesn't start out as an active agent. Instead, pyrazinamide is a prodrug, meaning it needs to be converted into its active from inside the bacteria to do its job. When a person takes pyrazinamide, the drug is absorbed into the bloodstream and circulates throughout the body. The tuberculosis bacteria, called Mycobacterium tuberculosis, can take up the drug through passive diffusion. Inside the bacterial cell, an enzyme called pyrazinamidase, which is encoded by the P and CA gene, converts pyrazinamide into pyrazinoic acid, or POA. This conversion is essential because POA is the molecule that actually kills the bacteria. The activity of POA depends heavily on the environment inside the bacteria. In the acidic conditions often found in lung lesions where TB bacteria hide, POA can leak out of the bacterial cell. Outside, it becomes protonated, meaning it gains a hydrogen ion, which allows it to diffuse back into the bacterial cell. This cycle causes POA to accumulate inside the bacteria, disrupting their internal environment. Scientists once thought POA might block fatty acid synthesis, but recent research shows it mainly acts as a protonophore. This means it disrupts the bacteria's energy production by interfering with the proton motive force across the cell membrane. This disruption makes the inside of the bacterial cell more acidic, damages the cell membrane, and ultimately leads to bacterial death. Some studies suggest POA might also interfere with other vital processes like protein synthesis and energy metabolism, but its main action is to disturb the bacteria's energy balance. Pyrazinamide is especially good at targeting dormant or non-replicating TB bacteria, which are often resistant to other drugs. This ability helps shorten the overall treatment time and improves the chances of curing TB when used with other first-line drugs like isoniazid, rifampin, and ethambutol. Resistance to pyrazinamide usually comes from mutations in the P and CA gene, which prevent the enzyme from converting the drug into its active form. Without this conversion, pyrazinamide can't work. That's why testing for P and CA mutations is important, especially in cases of drug-resistant TB, to guide effective treatment. In summary, pyrazinamide works as a prodrug by being converted inside the TB bacteria into pyrazinoic acid, which then disrupts the bacteria's energy production and internal environment, leading to bacterial death. Its unique ability to target dormant bacteria makes it a vital part of TB treatment worldwide. If you or someone you know is being treated for TB, always consult healthcare professionals for personalized advice and care.